Hello guys, welcome to the channel. In this video, I'm going to show you an interesting project called as Modified Beam Sampler. Before I show you anything about this project, let's first try to understand in very simple words as what exactly is meant by this beam sampler. In machine learning, a beam sampler is a component used in a sequence to sequence models, particularly in natural language processing tasks such as machine translation, text summarization, and speech recognition. The beam sampler is responsible for selecting the most likely candidate sequences, or in other words, beams, from a set of possible sequences generated by the model. And sequence could be a combination of text or token or characters, depends upon the model. So sequence and beam are same thing. This is done by assigning a score to each sequence based on its probability of being the correct output. So that is what beam sampler does. Let's look at it step by step. So what happens is whenever we ask a question from a model, the model generates a set of possible output sequences. Then each sequence is assigned a score based on its probability of being the correct output. The beam sampler then selects the top scoring sequences or beams based on specified beams width or hyperparameter. It could be randomness, top P, top Q, or whatever. And then the beam sampler prunes the less likely sequences, reducing the computational load. And then it just keeps repeating all of these steps until the end of the sequence is generated or a maximum output length is reached. The beam sampler improves the efficiency and accuracy of sequence to sequence models by reducing the computational load by pruning less likely sequences. It also increases the chances of selecting the most likely correct sequence, plus it allows for more efficient exploration of the sequence space. So this is what beam sampler does, and it is very commonly used in machine learning models and algorithms. You don't see it much of often outside. So that is why this project, which is an open source project free on GitHub, this has tried to modify the existing beam sampler. So in this video, what I'm going to show you, I'm going to apply this modified beam sampler code on an existing open source model, and then we will see how we go. So we will be downloading the model and then we will be using some code to generate some long context sequence. Also, most of the code is taken from this GitHub repo, so I will drop the link to it in video description, so if you're interested you can read through. I'm not going to go into the nitty-gritty of the code because that is most of it is really not required to use, but just to understand this beam sampler concept, I think it will be an interesting exercise. Okay, so before I show you how to start, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. This is my Ubuntu terminal where I'll be installing a Jupyter notebook, and then we will be doing everything in that notebook. This is my NVIDIA GPU card of 48 GB of VRAM, NVIDIA RTX A6000. Okay, so let me clear the screen and launch my Conda environment. So this is where I'm creating the Conda environment called as Beam and then activating it. Let's wait for it to get installed and activated. There you go, all done. Let's install Jupyter Notebook, and then it is going to launch that notebook in my browser window. So let's wait for it to get launched. So our notebook is launched. Let's first git clone the repo of this modified beam sampler. Let's wait for it to finish. Shouldn't take too long. Repo is cloned and I'm just installing now Flash Attention. Let's wait for it to finish. And that is done. Let's also install Bits and Bytes and Accelerate for optimization. And that is also done. I already have Torch installed in my system, so I'm not installing it. So if you don't have Torch Transformer, then make sure to install the Torch and Transformer. Let's import the stuff which we have just installed. So I'm just going to import Accelerate, Torch, and all that stuff. So let me run it. And that's done. Now let's define a simple class for the sampler. So if you look here, what we are just defining this class config with some of the hyperparameters, and then we are simply using this completion API function with some output with some random parameters, and then it is going to generate the output, and then tokenizer will decode the output and we will print it out. So let me run it. That is done. Okay, let's proceed further. And now let's define our recursive sampler. Now, instead of going into this whole code, let me give you a brief synopsis so that you know what is happening. So what we are doing here is we are defining or implementing a recursive beam search algorithm for text generation using a model, which I will show you shortly. Now, the recursive sampler step function, which you can see here, generates the next token in a sequence using a beam search approach. So as you can see in the input parameters, it takes in the current output sequence, beam length or sequence length, temperature, which determines the randomness of the response, top K, top P, which controls the output, and some other parameters. It then, if you go down, it then uses the model to generate the next token, and then it applies temperature scaling and then calculates probabilities. It then applies top P and top K filtering and samples the next token using multi-nominal sampling. The function then returns the updated output sequence, the sum of score, and a flag indicating whether the sequence has terminated. And then you see that it is also using some of the logits. Logit is the input to the sigmoid function, which maps any real valued number to a probability between 0 and 1, and is typically used as a raw output of a model before applying the sigmoid function to get the predicted probability. Also, other than that, this recursive function is the main entry point for generating text. It takes in the input text and maximum token and other stuff, and then once the generation is complete, it decodes it decodes the generated text and returns it. So all in all, this code is using a recursive beam search algo to generate text by iteratively sampling the next token in a sequence, applying filtering, and then temperature scaling and updating the input sequence for the next iteration. So this is the whole synopsis of this code, and you don't have to really worry about more detail here. And now let's load our model for scaling. So I'm just going to insert a cell here and then show you this. So you see here, we are just using some of the scaling and sampling, and then we are loading this Nous Research Hums to approve Llama 3 8 billion, and I'm just loading it in 8-bit just to reduce the size. And then I'm just using this rope scaling here. So let me run it. So you see it has started downloading the model. Let me scroll down, and there are 4 tensor. Each size is 5 gig. And hopefully it will fit on my GPU. So let's wait for it to finish downloading. And the model is loaded here with its tokenizer. Let's specify a prompt. So I'm just saying you are a sentient super intelligent AI general AGI here to teach and assist me, and then write a long story about someone. Let's set the prompt here. That is done. And now let's first do let's generate the completion with default transformer sampler and recursive one. So for that we will just use our own function we defined above with simply these tokens. Let's see what it generates. So there you go. So if I go down and let's wait for it to print it. So there you go. So I've been waiting for like 10 minutes and it is still working. So that is the problem is with this completion. So I'm canceling it, and we will try it out with the beam function. So I just canceled it just to make sure that we just wanted to see the slowness here. Now let's go to the next cell, and then we will try to give it with the beam. And now let me run that recursive sampler with number of beam 3, beam length is 5, and then some temperature. And you can of course change the prompt as you like. So let's wait for it. I think it is still running the previous one. Let me cancel it. Let me put the focus on this one. Yep. And now let me run it. Okay, so I just need to define that because I didn't define it above. Let me quickly do that. So there in this cell, when I was actually describing it, I forgot to run it. So let me run this one, the recursive sampler one. And there you go. You see, When I run it now, it has given me the response here within a split second. How good is that? So I would say amazing project, especially when it comes to improving the inference speeds for a long context models. Even the older one really looks good. I know it could be a bit dense, that all this sample and stuff, because normally these things remain hidden from our attention, but it's always good to know and just peek behind the scene under the bonnet to see what is happening. And this was just an attempt to show you that when this beam sampler is used, especially when they modify it or when we employ it, instead of simple transformer as such, this could speed things up. So there are various ways where we could speed things up in addition to what we have seen in LoRa adapters and stuff. So that's it, guys. I will drop the link to this repo in video's description. You can find the code there, but there is a bit more information. And then you can, of course, search it anywhere for, if you are interested in learning more under the hood mathematics and stuff around this beam sampler. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.